Welcome back. And I'm still sorry. I'm still sorry about the pun I made where I said that p values are critical. Even though it's true, it's still an unfortunate play on words. P values are critical. So here's what happens when you make your claim, where you say, for instance, 30% of adults sleepwalk. Then, if your null hypothesis is true, if exactly 30% of adults sleepwalk, then your samples should be normally distributed around that value of 30%. And that's true whether you say that exactly 30% sleepwalk, or at least 30% sleepwalk, or at most 30% sleepwalk. Assuming the null hypothesis is true, you should get some form of normal distribution. Actually, you should always get some form of normal distribution because we actually assume that. But anyway, you should get some form of normal distribution that is centered at 30% or zero point 0.3. And that's true for all three of these graphs. You got some normal curve. The mean here, the center point, the axis of symmetry is at 0.3. If you say your null hypothesis is p equals 0.3. Same if it's equal to or not equal to, less than or greater than. In all of those cases, assuming the null hypothesis is true, which we're about to do, it should be centered at that value for the proportion or for whatever other statistic you're testing. So what the p-value does is it finds the area of what's called the critical region, which is to say the region that is so far removed from the null hypothesis that it cannot be supported by the null hypothesis. And this one, I wish I could say that it's going to equal alpha. I mean, that would be the dream. Really, the dream would be that it's greater than that, but so that it has to be supported by alpha. But really, it's just whatever is so far removed from the null hypothesis that the null hypothesis can no longer support it. And we want to know how big that region is. If this region out here is really big, we're in trouble because our hypothesis does not support enough of the cases. If this region is very small, then we might be okay because the null hypothesis covers most of the cases. So again, for our example here, we had 27 adults, 5 sleepwalkers. That comes out to be like 18%, I think, as the sample proportion here. So again, it should be the case that we get exactly 30%. We didn't. So based on our sample, what is the probability that we got something that should have been created with the null hypothesis? So one way to test that is by finding these critical areas. And you find these critical areas using this test statistic. And we'll crunch those numbers in the next video. It'll be a blast. I promise you that. It'll be a blast. But you'll see here we've got this test statistic involving p hat, that's our sample proportion. Regular p, that's our population proportion. Then we've got q, which is, of course, the converse of that, the complement of that. And then in our sample size. So we can calculate this critical value, in essence, a critical value, and then we will use this to find the p-value, because we will use that to find the critical region. Conversely, if you're not hip to that, you can also use these various calculators to do that for you. If you read it in the text, your author has this weird love, obsession even, with the TI-83 calculator. I don't really want to teach that to you guys. Besides, we live in the future. These are much better, and I'll show you that in the next video. So I'll stop it here, and we will start calculating p-values with and without using test statistics in the next video. See you then.